again, you need to be really careful with what's being asked. Okay, so what if I ask you what properties or what conditions are sufficient to prove that a quadrilateral is a rectangle? Okay, so now we start with a quadrilateral and we're showing that it's a rectangle. Okay, so again, when you're looking for these, usually the definitions are a part of what will be those conditions. So in order for you to have a rectangle, you need to have a quadrilateral with what? What's part of its definition? Got it.
Has 4 right angles.
Okay, good. So the one sufficient condition to show that a quadrilateral by itself is a rectangle is that all 4 angles are right angles. Okay, and again, it's pretty much repeating its definition, and so that would guarantee for you that you're dealing with a rectangle. And now there's a couple other properties that are sufficient conditions to show that a parallelogram is a rectangle. Again, notice that it starts with a different supposition. So here, suppose you're beginning with a parallelogram. And you want to show that it's a rectangle. So there's a little more specifics in this because all the properties of a parallelogram are already implied. So what other things beside the properties of a parallelogram are sufficient conditions to prove you're dealing with a rectangle? Luke? Good. Okay, if you have a parallelogram with congruent diagonals, that's enough to show that you have a rectangle. Now, this property is not enough to show that a quadrilateral is a rectangle. The reason for that is if you looked at an isosceles trapezoid and you drew in the diagonals of that, those diagonals are in fact going to be congruent to each other. But is this a parallelogram? No. So the reason this statement has to also include the parallelogram is because you could be dealing with a trapezoid as well. Okay, and then there's another one. Okay, and the other one is if you have a parallelogram, how many right angles would you minimally need to see in it in order to prove that it's a rectangle? 1. Okay, so if you have a parallelogram and it has at least 1 right angle, all you need is 1, because then what do you know about the opposite angle? Opposite angles in a parallelogram are equal, so the opposite one will be a right angle. And what do you know about consecutive angles in a parallelogram? They're same side interior angles, therefore they are supplementary. The supplement of 90 is 90, and so you'd wind up with all 4 of them if you just had the one. Okay? So these would be the sufficient conditions for a parallelogram to be proven to be a rectangle.